Hi, welcome to Venkat Verma Chemistry YouTube channel. I am Venkat Verma, your host and chemistry enthusiast. I hope all are doing well. First of all, very thankful to clicking the video. So, in this session, I am going to explain tricks for bond length. Tricks for bond length. See, let's start our session. Bond length. So, what is mean by bond length? See, the equilibrium distance between the nuclei of two bonded atoms in a molecule is called as bond length. Equilibrium distance between the nuclei of two bonded atoms in a molecule is called bond length. See, bond length, it's depending on following factors. What are the factors affecting on bond length? See, the following factors are size of atoms, number of bonds, the electronegativity difference, and the percentage of the S character, and resonance. These factors are affecting on bond length. Let's move on. Bond length. See, the equilibrium distance between the nuclei of bonded atoms, the equilibrium distance between the two nuclei atom is the bond length. This is the bond length. See, bond length depending on following factors. What are the factors? Size of bonded atoms, number of bonds, electronegativity difference, percentage of the S character, and resonance. So we can discuss one by one the following factors. The first factor is the size of atoms. The first factor is the size of atoms. See, generally bond length is directly proportional to size of bonded atom. Size of bonded atoms. The very first factor is the bond length is directly proportional to size of bonded atom. See, what it means? Size of atom increases, bond length increases, size of atoms increases, bond length increases. Let's take example. For example, I am taking example. See, hydrogen iodide, hydrogen bromide, hydrogen chlorine, and hydrogen fluorine. See, Hi, HBr, HCl, HF. See, what is a common? Common is a hydrogen. Common is a hydrogen. See, fluorine, okay, chlorine, see, bromine, and iodine. So, the size of bonded atoms increases, bond length increases. So, which is more bond length? Obviously, hydrogen iodide, hydrogen bromide, hydrogen chloride, hydrogen fluoride. This is the order of bond length. CHI, CHBr, CHCl, and HF. This is the first factor effect on bond length, size of bonded atom. Bond length is directly proportional to size of bonded atoms. Let's move on. Second factor, number of bonds. See, the second factor is the number of bonds. What is the relation between number of bonds and bond length? See, bond length is inversely proportional to number of bonds. Bond length is inversely proportional to number of bonds. What it means? For example, number of bonds decreases, bond length increases. Number of bonds decreases, bond length increases. I'm taking example for this. See, for example, carbon carbon triple bond, carbon carbon double bond, and carbon carbon single bond. So number of bonds increases. See, number of bonds decreases. See, it is a triple bond, it is double bond, it is single bond, which has more bond length. So it is a carbon single bond, carbon double bond, after that carbon triple bond. See, number of bonds increases, bond length decreases. What is the relation? Inversely proportional. Number of bonds and bond length. Bond length is inversely proportional to number of bonds. Yes. Have a look for the next factor. See, electronegativity difference. Electronegativity difference. See, what is the relation? with the bond length. See, bond length is inversely proportional to delta En, means electronegativity difference. Electronegativity difference. Bond length is inversely proportional to electronegativity difference. See, let's take example. For example, I am taking, say, hydrogen HF, see, HCl, HBr, HI. Yes. So what is electronegativity of hydrogen? It is nearly 2.1. See, what is the electronegativity of fluorine? Fluorine is, it is a 4.0. What is electronegativity of chlorine? It is a nearly 3.0. What is electronegativity of bromine? It is 2.8. What is electronegativity of iodine? It is 2.5. So hydrogen is a common, it is a 2.1, 2.1, 2.1. See, what is the difference? What is electronegativity difference in hydrogen fluoride? So 4.0 minus 2.5, it is nearly, what is, it is 1.9. Difference is HCl. What is the difference? It is nearly 0.9. Yes, 0.9. It is nearly 0.7. Yes, it is nearly 0.4. So what is the electronegativity difference? Electronegativity difference, which is more? So it has delta En is more. Yes, it is high. Delta En is low. Which has low, that has more bond length. Yes, after that hydrogen bromide, hydrogen chloride, hydrogen fluoride. So delta En high HF, delta En low is a 0.4. This is the relation, electronegativity difference and bond length. Electronegativity and bond length. See, next go for next factor. See, next factor. See, percentage of the S character. Go for the percentage of the S character. See, what is the relation between bond length and percentage of the S character? So bond length is inversely proportional to percentage of the S character. Percentage of the S character. Yes, generally sp hybridization, sp2 hybridization and sp3 hybridization. So what is a S character in sp hybridization? It is a 50 percentage. In S character in sp2 it is a 33 percentage. In sp3 it is a 25 percentage of the S character. Yes, so sp, sp2, sp3, this is the percentage of the S character. Percentage of the S character. See, bond length is inversely proportional to percentage of the S character. Yes, let's take an example. Carbon carbon double bond with the H. Yes, carbon carbon single bond. Carbon carbon single bond. Yes, so what is the hybridization of this carbon? It is sp2 S3 sigma 1 pi. It is sp3 hybridization. It is a sp3 hybridization, which is more percentage of the S character, sp2, after that sp3. So sp2 and sp3. sp3. So bond length relation between sp2 and sp3. So sp3 has more bond length than sp2 hybridization. sp2 hybridization. Yes, this is a percentage of the S character. This is a percentage of S character. See, I will look for the next factor, resonance. Look at for resonance. Look at for resonance. See, carbon carbon single bond taking part in resonance is shorter than expected. Shorter bond length than expected. Carbon carbon double bond taking part in resonance is larger than expected. Single bond taking part in resonance is bond length is shorter than expected. Carbon carbon double bond taking part in resonance is larger than expected. These five factors are affecting on bond length. See, have a look for example for resonance. I am taking example for the resonance. Have a look for example. Have a look for example. See, if I am taking CH3, CH2, Cl, CH3, CH2, Cl, and CH2 double bond CHCl, and benzene with chlorine. See, is it possible in resonance in first one? So it is lone pair sigma. Lone pair sigma, there is no resonance. There is no resonance. So it has no resonance. There is no resonance structure. Have a look for this one. See, it has lone pair sigma. Lone pair sigma pi. So lone pair sigma pi. So these lone pairs are shifted to sigma bond. This pi bond is shifted to carbon. So what is the structure? CH2 CH double bond plus, yes, it has negative charge. How many resonance structures? So it has two resonance structure. It has two resonance structure. See, have a look for third example. Have a look for third example. See, this one, chlorine has lone pair of electron, lone pair sigma pi. So it has C. Look at for resonance structure. See, it has carbon chlorine double bond with positive charge. It has a negative charge. Yes, this negative shifted to this carbon and this pi bond shifted to this one. See, have a look at for resonance structure. See, yes, here negative charge. Yes, and again look at for this carbon with the chlorine double bond. Now we are getting partial positive charge, here negative charge. They shifted here. See, yes. So how many number of resonance structure? It has 5 resonance structure. Number of resonance structure is the 5. So what is the order of bond length? See, what is the order of bond length? What is the order of bond? It is the first one, it is second one, it is third one. Which has more bond length? Here carbon chlorine no resonance, it has more bond length. It has more bond length. First one, it has a 2 resonance structure, it has 5 resonance structure. Compare these two, second one is more bond length, and after that third one. This is the order of bond length in the following compounds. See, these are the tricks for finding of bond length based on following factors. See, have a look for test yourself question. So compare the bond length of CH3 CH2OH, CH2 double bond CHOH, and benzene with phenol. Let's find the answer. Send in the description. Okay. See, I hope like this video. Don't forget to share your friends. Don't forget to give the like. If content is valuable, make sure to subscribe our channel for more updates. Thanks for watching.